Okay, we are going to talk about inelastic collisions. And I'm going to run through a problem for you, and then you're going to do some problems, and you're going to behave while I'm not here. All right? The first thing is we watched an eagle pick up a fish the other day. So here's our little eagle flying through the air, and he's got his little feet out, fixing to pick up a fish. And down here's our fish. It's at the top of the water. All right. Now remember that an inelastic collision is when things stick together. So that's the first thing that we need to remember. We have a bird here, an eagle, and let's give him a mass of 100 kilograms. And he's going to be traveling in, let's say, 20 meters per second. So if I know the mass is this and the velocity is this, then I can figure out the momentum of this situation. And what I'm wanting to do is when this bird flies down and picks up this fish, he's going to gain some mass, and so he's probably going to slow down. And that's what I want to try to find out is what is that number? What is that velocity that he slows down to? So we're going to start with this concept of momentum equals mass times velocity. And momentum then is going to be 2,000 kilograms meters per second. All right, so that is my initial momentum. Now this problem becomes pretty easy because I'm going to give the fish a mass of, let's say, 10 kilograms. It does not have any velocity, so therefore it has no momentum. All right, so the law of conservation of momentum tells us, the law of conservation of momentum tells us that whatever we start with, whatever momentum we start with, we have to end up with. So in this system, all that we start with is a fish, and we start with this fish right here, and we start with this bird right here. All right, and so the momentums of those two things together, when you total them up, obviously this one has 200, excuse me, that's a bad little pen there. All right, the bird has a momentum of 2,000 kilograms meters per second, and the fish has 0 kilograms meters per second. So the total is 2,000 kilograms meters per second. That's before. So with the law of conservation of energy says whatever you start with is what you have to end with. So we've started with 2,000 kilograms with these two objects. So after the bird flies down and picks this thing up, then the momentum of those two still has to equal 2,000. All right, so that's good information, and therefore we can solve for a few things with that knowledge. Okay, so now watch this. Since the original momentum is 2,000, then that means after the fact the momentum has to be 2,000 also. Kilograms meters per second. All right, and now we want to try to figure out what the velocity is, and we can do that because we have the masses after the bird flies down and picks this up. Now we have a bird with a fish in his claws, so we have a bird with a mass of 100, and we have a fish with a mass of 10, so now their masses combined is 110 kilograms. So now I can solve this little formula here, P equals mb, because I know 2,000, I know mass 110, and I can do some math, and I'm going to punch it into my little calculator over here on the table. 2000 divided by 110 equals 18.18, and that's meters per second. So now these two, the fish and the bird, flying through the air at 18.18 meters per second. And that makes a lot of sense because at the end of the day, I'm going to use yellow. You can see that it slowed down because the the bird, the eagle, was flying at 20 meters per second. It flies down, picks it up, because it gets adds more mass to it, and it flies off with that mass, then it has to slow down. And that's what you're going to do today. Now, in addition to that, you could use this notion of kinetic energy. And if you remember, I'm going to write that. I'm going to do it right here. Kinetic energy equals 1/2 mv squared. And since we know the masses of these things and the velocities of these things, we can determine the kinetic energy of the bird before it picks up the fish, and we can determine the kinetic energy of the bird and the fish after they've been picked up. After he's picked them up, we can determine the kinetic energy of that. And you'll find out that it should lose some kinetic energy. Once the bird picks this up, there should be a loss of kinetic energy. I'm just saying, maybe that shows up somewhere on your worksheet today. You're awesome. Have a great day, and behave while I'm gone.